Hi guys, today we're going to be looking at moles and solutions. We'll be looking at concentration and how you calculate concentration, moving from decimeters to centimeters cubed and back again, and also we'll apply this to some problems, so hopefully it'll give you the heads up that you're going to need. Okay, so firstly starting off, solution concentrations. Now these can be expressed in two different ways. You can be given grams per decimeter cubed or moles per decimeter cubed. Now to find the concentration in terms of grams per decimeter cubed, you do the mass divided by the volume. But more commonly, the concentration was given in moles per decimeter cubed. The concentration is the number of moles divided by the volume. And this triangle here makes life a lot more easier, because if you go to this one and you need to find the number of moles, you're going to have to do a bit of a conversion with the molar mass here. Now, annoyingly, lots of problems, they come in centimeters cubed. You'll be given the volume of a solution in centimeters cubed, but for our equations, centimeters cubed is no good. We're going to need decimeters cubed over here. So to go from centimeters cubed to decimeters cubed, you divide by 1,000, and we'll see examples of this shortly when we go through some problems. If you do need to go back though, if you've got an answer in decimeter cubed and you need to take it back to centimeters cubed, well, you just times by 1,000. So just be aware of volume conversions here. Okay, so what I've drawn here is a battle plan of how we're going to solve some solutions problems. So firstly, we're probably going to be given the volume of a solution and also the concentration, but be wary, the volume is probably going to be in centimeters cubed and we're going to need to convert. So using concentration and volume, we're going to end up finding out the number of moles. We're then, once we've found the number of moles, going to look at the ratio in our chemical equation to work out how many moles we've got over here. Then either, if we're asked to find a volume, we'll do the moles divided by the concentration, or if we're asked to find a mass, we'll do moles times the molar mass and we'll find out the value of our mass. Okay, let's start off. What mass of magnesium reacts with 100 centimeters cubed of 2.0 moles per decimeter cubed hydrochloric acid? Okay, so firstly we're going to be looking for mass at the very end. They've given us a volume, but of course it's in centimeters cubed. So dividing by 1,000, we've got 0.1 decimeters cubed. We've got our concentration here, and it is in moles per decimeter cubed. Okay, so let's start off. So we've got our volume, which is 0.1 decimeters cubed, and then by multiplying by the concentration, which is 2, we're going to find out the number of moles. So we've got 0.2 moles of hydrochloric acid. Now here, what's our ratio? It's a 2 to 1. So if we've got 2 over here, we're going to have 1 over here. So what we need to do is 0.2 times by 1 divided by 2, which is going to give us 0.1. So we've got 0.1 moles over here. Okay, next up, we're looking for mass. So we need to times the number of moles by the molar mass of magnesium. Now we've got 0.1, and on the periodic table magnesium is 24. So 0.1 times by 24 is 2.4, and that's going to give us a mass of 2.4 grams of magnesium, and that is our final answer. Okay, here we go again. What mass, okay, so after a mass of calcium carbonate reacts with 4 decimeter cubed of 1.5 moles per decimeter cubed hydrochloric acid? So again, we're going to start off with volume, and our volume is 4. Remember, this time we don't need to convert, they've given us it already. So 4, and then how many moles are we going to have? So 4 times by 1.5 is 6 moles. Now have a look at the ratio. We're talking about hydrochloric acid and calcium carbonate, so it's a 2 to 1 ratio, and this is what we're looking for. So it's 2 to 1 over here. So we've got 6 moles, so 6 times by 1 divided by 2 is 3 moles. And then finally, we want to find out the mass. Now, calcium, let me just look at my periodic table, is 40. So calcium is 40 plus 12 for carbon, and then we've got brackets 3 times 16, and we get a molar mass of 100. So 1 mole is 100 grams, but we've got 3, so 3 times 100 gives us 300 grams, and that's our final answer. Okay, what volume of 0.1 moles per decimeter cubed sulfuric acid reacts with 1 gram of zinc powder? It's a slightly different problem this time. This time we're dealing with a mass to begin with, but it's not a problem, we can still convert to moles. So we've got our mass is 1 gram, and we want to know is, well, how many moles of zinc have we got? Well, the molar mass of zinc is 65, so 1 divided by 65 is going to tell us the number of moles. 1 divided by 65, and I get, well, let me just write 1 over 65 here. Now let's look at the ratio. Well, it's a 1-to-1 ratio, so that makes life easy. So we've got 1 over 65 moles of sulfuric acid. In the last part, we want to find out the volume. Okay, so we need to do 1 over 65 divided by the concentration, which is 0.1. And we get 0.153 decimeter cubed, and if I times that by 1,000 I get 153.8 centimeters cubed, and that is our final answer. Okay, next up, what volume of 0.1 moles per decimeter cubed of sulfuric acid reacts with 30 centimeters cubed of 0.15 moles per decimeter cubed sodium hydroxide? So we're given a volume, but it's in centimeters cubed, so 30 divided by 1,000 gives us 0.03 decimeters cubed. So we've got our volume 0.03, and if we multiply by our concentration, we are going to get how many moles we've got. So 0.03 times by 0.15, and we get 0.0045 moles. Okay, next up, let's have a look at the ratio, and the ratio is 2 to 1. So here we've got 2 to 1, so 0.0045 times by 1 divided by 2, and we get 0.00255 moles. Then lastly, we want to work out the volume, so we're going to divide by 0.1 here. So 0.00255 divided by 0.1, we're getting an answer of 0.0255. Now that's decimeters cubed. If we want to convert to centimeters cubed, times that value by 1,000, and we get an answer of 25.5 centimeters cubed. That's our final answer. Okay, last one. What mass, of sodium hydrogen carbonate, which is here, is needed to neutralize 50 centimeters cubed of 0.75 moles per decimeter cubed sulfuric acid? Well, again, they've given us centimeters cubed, so we need to convert to decimeters cubed by dividing by 1,000. So we get 0.05 decimeters cubed. So let's start off here. So we've got 0.05 decimeters cubed. How many moles do we have? Okay, well, the concentration is 0.75, so times this by 0.75, and we get an answer of 0.0375 moles. Then we're going to go across to, okay, let's have a look at our ratio. So we're looking at a ratio of 1 to 2, but we started off with the sulfuric acid, so we've got a 1 here and a 2 here. So we're going to do 0.0375 times by 2 divided by 1. And we find that we've got 0.075 moles of our sodium hydrogen carbonate. Now lastly, we want to work out what's the mass, so we just need to have a look at, well, what's the molar mass? So sodium is 23, we've got hydrogen is 1, carbon is 12, and oxygen, we've got 3 of them, so it's 3 times by 16. So the molar mass of sodium hydrogen carbonate, so we've got 23 plus 1 plus 12 plus 3 times 16, and we get 84. So finally 0.075 times by 84. This is going to tell us the final mass. We are going to need 6.3 grams. That's our final answer.